Hi everybody, Mrs. Pesic here. We are looking at summer video number 2, and the topic is domain of an algebraic expression and interval notation. The set of real numbers for which an algebraic expression is defined is the domain of the expression. So let's take a look at this example. Find the domain of this expression. Well, this is a polynomial expression, and that means you can plug in any number you want for x, and there won't be any problem. It will always be defined. It will never be imaginary. It will never be undefined. So we would say our domain here is from negative infinity to positive infinity. All right, this is called interval notation when we use parentheses and we show the infinity signs. All right, let's take a look at this example. What would be the domain of this expression? Well, here we can plug anything we want in for x, but we do have to watch out because we have a denominator and we cannot divide by 0. Divided by 0 is undefined. So for this problem, we would say that our domain is all real numbers except the number that's going to make our denominator equal to 0. So set x minus 3 equal to 0, add 3 to both sides, and you get x equals 3. So if I was to plug in 3 into this expression, I'd have 5 plus 3 over 3 minus 3. That's going to be 8 divided by 0, and that does not exist. That's undefined. All right, so in this case, our domain would be everything from negative infinity to 3, but we don't want to include the 3, so we would use a parentheses, union with from 3 to positive infinity. Again, the parentheses here and here mean that we don't want to include the 3 in our solution set. All right, let's take a look at this example. Well, here we want to find the domain of this expression, and we can plug anything we want in for x except if it's going to make our denominator equal to 0, because we are not allowed to divide by 0. So let's set x squared minus 25 equal to 0. And we could add 25 to both sides, so I get x squared equals 25. Then I'm going to take the solve for this. I'm going to have to take the square root of both sides. Do you remember that if you're taking the square root of both sides in the equation, you need to remember the plus or minus? So we would get x equaling plus or minus square root of 25, which is 5. That means we need to kick 5 out of the domain, and we need to kick negative 5 out of the domain. So in this case, we could say the domain is all real numbers, negative infinity to positive infinity. X cannot equal 5, and x cannot equal negative 5. Now, if we were going to write this with proper interval notation, we would really write it negative infinity to negative 5 with the parentheses to show that we don't want to include that. All right, union with everything from negative 5 to positive 5, union with 5 all the way to positive infinity. Okay, we always use parentheses with the infinities. So, in other words, on our number line, we can have everything from this all the way up to negative 5, but not including the negative 5. Then we can have everything in this interval from negative 5 to positive 5. And then we can have everything in this interval from 5 on. So, again, we're talking about intervals like this. All right, let's take a look at this next example. 5x plus 6 over x squared plus 3. Again, we want to make sure that whatever we're plugging in for x is not going to make our denominator equal to 0. So I'm going to set x squared plus 3 equal to 0 and solve. So I'm going to subtract 3 from both sides, and I get x squared equals negative 3. But now if I try and take the square root of both sides, then I end up getting x equaling plus or minus the square root of negative 3. And I cannot take the square root of a negative number and stay in the real number system. So that's why there is no x value that's going to make our denominator equal to 0. So that's why our domain for this problem, domain for this example here, is all real numbers. And we're going to indicate that by writing negative infinity to positive infinity. All right, so let's find the domain of these algebraic expressions. This time, slide these down a little bit more room here. So this time, for this first one, we want to find the domain of this algebraic expression, square root of x. Well, what numbers am I allowed to plug into a square root? Well, I just can't plug in any negative numbers because then I'm not going to be in the real number system anymore. So in this case, whatever's under the radical has to be greater than or equal to 0. So it's okay to take square root of 0. It's okay to take square root of 1/3. It's okay to take square root of 0.99. It's okay to take square root of 100. We can plug in anything that's greater than or equal to 0. So this would be our domain, but if we're going to write it in interval notation, then we would write it like this. We want to go from 0 all the way to positive infinity. Notice I'm using a bracket here, and bracket is indicating that we do want to include the 0. Okay, so this domain includes the 0 because we're using the bracket. All right? Let's take a look at this example. So let's slide this down a little bit. That's not very well hidden, is it? Let's try this. Okay, so now for this next example, we want to know what is the domain for the square root of x minus 3. So again, we know that we have a square root radical, that nothing underneath could be negative. So we want to make sure that x minus 3 is going to be greater than or equal to 0. So we need to solve this inequality. We're going to add 3 to both sides, and we get x is greater than or equal to 3. And that's our domain. So we know that our domain for this problem is going to be from 3 to positive infinity. Do we want to include the 3? Yes, we do, because we're saying greater than or equal to. So that means we want a bracket there, not a parentheses. All right, let's take a look at this example. What about the domain for 5 minus 2x? Well, I'm sorry, the square root of 5 minus 2x. Again, if we want the domain for this, we want to make sure that whatever's under the radical has to be greater than or equal to 0. So this is what we want to solve. So in this case, we're going to subtract 5 from both sides. So I get negative 2x is greater than or equal to negative 5. I need to solve this inequality for x, so I'm going to divide both sides by a negative 2. But you remember how this works. Anytime I multiply or divide both sides of an inequality by a negative number, I need to switch the direction of the inequality. All right? I don't like when people say you got to change the sign. That doesn't even make any sense. So don't say that. Instead, say when I multiply or divide an inequality by a negative number, I need to switch the direction of the inequality. So in this case, I'm going to have x, and instead of greater than or equal to, I'm going to have less than or equal to, and negative 5 over negative 2 is the same as 5 over 2. So in this case, any x that we plug in into this expression has to be less than or equal to 2.5 or 5/2. How are we going to write that domain now using interval notation? Well, we're going to say we want to go from negative infinity all the way up to 5/2. We always use a parentheses with infinity and negative infinity. But the 5/2, we do want to include that because this is a less than or equal to here. So we do need a bracket here. So that's our domain for that example. All right, so let's take a look at these examples. Find the domain for each expression. So for this first one, the expression is 3 plus x over square root of x. So in this case, we have two things to contend with. First, we see a square root, and we know that whatever's under the square root has to be greater than or equal to 0. So you might say, okay, I'm going to solve this where x has to be greater than or equal to 0. But wait, that square root is in the denominator, which means you can't have it equal to 0. So that means I don't want to write x greater than or equal to 0. I just want x strictly greater than 0. I can't have negative numbers under a radical, and I can't have 0 in the denominator. So this is our domain. But if we're going to write it using interval notation, we're going to say we want 0 all the way to positive infinity. But I don't want to include 0. So am I going to use parentheses or a bracket? I'm going to have to use a parentheses to indicate that I do not want to include 0. Let's take a look at this next example. Here I have 7x over square root of 2x minus 3. So in this case, if I want to find the domain, what's under the radical has to be greater than or equal to 0, but it's in the denominator, So I can't have it equal to 0 either. So that means I want to set this whole thing strictly greater than 0. So I'm going to write 2x minus 3 has to be greater than 0, not greater than or equal to. And I'm going to solve this inequality by adding 3 to both sides and getting 2x is greater than 3, and then dividing both sides by 2. Do I need to switch the direction of the inequality? No, because I'm dividing by a positive number. So I'm going to have as my inequality solution, x has to be greater than 3 halves. So if I'm going to write my domain has got to be all x is greater than 3 halves. So I'm going to start with 3 halves and then go all the way to positive infinity. So I need a parentheses here, and I need a parentheses here because I'm not including the 3 halves. All right, that means 3 halves is 1.5. Well, that means I can include 1.501. I could include 1.523. I just can't include 1.5 itself because that will make my denominator equal to 0. All right, one last example here. So for this one, we have 19 minus x over square root of 5 plus x. We want to make sure that our denominator, we have to make sure our denominator is not equal to 0, and it's under a radical, so we need to make sure it's greater than 0. So we have 5 plus x has to be strictly greater than 0, so I'm going to subtract 5 from both sides, and I get x is greater than negative 5. So that means that my domain for this problem is going to be everything from negative 5 and above, so from negative 5 to positive infinity. We always use a parentheses with the infinities, but we want everything strictly greater than negative 5, not including it, so I'm going to use a parentheses here as well. All right. Okay, so that brings us to some extra practice problems. All right, so for these, I'm not going to work these out. You are, all right, on a piece of paper somewhere. You work these out and see if you can determine the domain for each of these algebraic expressions using interval notation. I would encourage you to work these out now, pause the video, and when you're done working them out, then start up the video again and you will see the solutions on the next page. Okay, so here are your solutions for these 3 problems. I hope you paused the video and worked these out. So your solutions for number 1, 2, and 3. Number 1, negative infinity to 1/3, union with 1/3 to positive infinity. Number 2 would be bracket, negative 4/3 to positive infinity. And then number 3 would be negative infinity to 7 halves, not including the 7 halves. All right, so hopefully you're feeling okay about these problems in this section and on this video, and you're ready for the quiz. If you have any issues or problems with the problems or answers on this video or with questions on the quiz, please feel free to send me an email. Here's my email address, and hopefully you will be very successful on this quiz. All right, thanks for watching. Oh, and remember, on the quiz, there will be 5 questions, and you need to get 4 out of the 5 questions correct and score an 80% in order to move on to the next quiz, in order to say that you've completed this. You can certainly keep trying and go for a 5 out of 5, but you need to get at least a 4 out of 5 to have this particular quiz passed. Thanks for watching.